Welcome to my channel SPS Physics Classes by S. Painda Sharma. Today, let us try to see a short topic that's called torque in the system. Equal to can done as R bar cross F bar, first formula, and this is nothing but you can done as RF into you can done as sin theta, means you can done as R sin theta into F, or you can done as F into F sin theta into you can done as R. So any one of the format we can choose here. Next, the magnitude of torque is actually defined as the rate of change of angular momentum, and then when you substitute the value of angular momentum, you can write down as I into omega. I is constant quantity right outside the differentiation, therefore I into d omega by dt we can write down. D omega by dt, nothing but what on alpha we can write down. Therefore torque acting on the system is nothing but I alpha we can consider here. As a result, finally, when you club the maximum torque, so maximum torque is nothing but theta is equal to 90 degrees only possible. So at maximum torque, we can consider that it is called as F into R we can use. So therefore, by using that term, F into R is equal to I into alpha we can write down, where alpha is given by A by R we can write down like this, where R is nothing but a perpendicular distance, and the same R only we can consider here. That means instead of capital R you can write down as small r. So by using this particular phenomenon, one can decide how much amount of force is applied when moment of inertia of the system I is given. I and alpha only given means use this formula to determine torque. Where do you get these torques? Generally in mechanics we have the torque in rotating motion problems, and followed by in electrostatics we have electrical dipole cases where torque is there, and in the magnetostatics we have vibration magnetometer experiment where the oscillation time period can be computed using the concept of torque again. Anyways, the next important thing is nothing but fourth one. Suppose some vector form is given. How to determine tau bar is equal to I j k, you can add rx, ry, rz followed by fx, fy and fz. By preparing what are a magnitude and then doing this particular value, you will get the value of torque tau. Now that suppose a group of torques are acts on system, then the tau net acting on system is equal to, you can write down as sigma tau I bars, that is nothing but tau 1 bar plus tau 2 bar plus dash 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 tau n bar, we can write down like this. Now in this particular case different forces are acting at the common distance of r. Under such a condition, you can write down as simply f1 bar plus f2 bar plus dash dash dash, you can fn bar into, you can write down as what, r bar, we can write down like this. So these are the important conclusions we have to take care for the torque. In the next case, in the torque, so in the given coordinate system x, y and z axes, okay, in this particular case we are applying a force of f bar in this plane with some inclination to the actual position vector of r bar. Then what happens? In this particular case, the force component can be resolved into components. One is parallel component, another one is perpendicular component. So therefore, total torque that is given by total torque or net torque is equal to, due to parallel component and as well as perpendicular component. Two components we have to conclude here. So parallel component will be given by here f cos alpha into r. So f cos alpha into r. And the angle between force and position vector is 0 degrees, therefore you can add on as sine 0 here together with, and perpendicular component is nothing but what here, f sine alpha into, what's the distance from point O, origin O to that of this special point P, distance is nothing but r only, you can take r into angle between force component and distance is nothing but here 90 degrees is there exactly, therefore you can add on as sine 90. As a result, torque net acting on the system is equal to simply f sine alpha into r. By using this particular formula, one can determine torque acting at this particular location. My dear students, in the examination, that person will give you with the confusing an angle, say here theta degrees they will give to you, theta degrees they will give to you. Then what we have to do is nothing but you have to take alpha is nothing but 180 minus theta in the problem. This angle only we need actually. Substitute that angle here and then try to find out the respective answer. Let us go to the next application. A wheel. Now we are visualizing actually in this direction. Okay, right. Now there is a wheel. This particular wheel experiences 4 different forces. They are given by F, 2F, 3F and F respectively. Now we need to calculate the total torque acting on the system. So how to find out the total torque acting on system? Let us try to identify. Now in the given case, we will try to consider this is the radius R you can take, R which is perpendicular to the force here. And here in this particular situation, this is the radius and exactly this radius and as well as force, okay, both are in the same direction. Therefore here angle is 0 degrees. Don't think that they are 180 degrees because the direction of R bar and F bar both are parallel to each other. Therefore you can take what? 0 degrees here. At this location exactly one more 90 degrees. At this location exactly we have, okay, one more 90 degrees. Totally this is the picture. Now by looking carefully, how many forces are there? 1, 2, 3, 4. 4 forces are there. Therefore net force is equal to first torque, second torque, third torque and fourth torque we have to write down. Now torque 1. The system is experiencing force in the clockwise direction. I mean that when the force is applied at this terminal, the whole system rotates in clockwise. Let us say for the clockwise rotation is positive, then you can take that is nothing but what, Anna? F1. That is nothing but force F into radius R. This particular torque acts in the clockwise direction. Therefore you write down as clockwise plus torque 2. Here because of the force of 2F at radius R, angle between them is 0 degrees. Therefore don't bother. And here because of 3F again produces clockwise torque of the system. Therefore 3F into what is the radius R we can write down. This whole system again the direction of clockwise, but the F in this direction, bottom direction, which produces exactly see this opposite torque to the axis. This is called clockwise and now this is anti-clockwise effect is produced. Therefore you can take it as FR in the anti-clockwise direction. Now clockwise, anti-clockwise FR gets cancelled. However, this component value is 0 and the final answer is nothing but 3 into F into R. In what direction the torque is acting? Clockwise rotation is leading with units of Newton meter. So this is the net torque acting on this particular system. Given case, what is happening? There is some spherical object. That spherical object contains a radius of capital R in the problem. Now we are being pulled at the center of mass with the force F. What happened? With respect to this particular point, the whole system right now undergone rotation. Under such a case, what is happening? So at equilibrium condition, that means this particular sphere neither goes down or not jumps up. In such a case, look at carefully. So this is the perpendicular distance and this is the force. So this will produce what type of rotation effect in this direction means? You are right, clockwise. Therefore, clockwise force F into R minus H, that must be is equal to. Now look at here, now with respect to this point, what is the distance here from here to here? X is the distance and force is nothing but mg. Therefore, mg and x will try to produce what type of effect? Reverse effect. So therefore, here you can write down as mg into x we can write down. What is the formula for x here? So F into R minus H is equal to mg into x is nothing but one of the adjacent side. So you can calculate using Pythagorean theorem as a root of what you write down here, R square minus of R minus H whole square. Using this formula, one can determine the required force for the balancing of this particular sphere. So if this particular force is nothing but a minimum force for the balancing process, that is given by F minimum is equal to mg of this entire value R square minus of r minus h whole square divided by r minus h is there. This is the minimum force. If you apply a force of F which is greater than the minimum force, then our external force starts domination over the system. So therefore, it starts motion in the upward direction. Like this, we can analyze some example problems in the given case. Thank you. Please subscribe my channel for further updates. Jai Hind.